Good afternoon, everyone. Today we're going to study 6.4, the central limit theorem. That's the title, the central limit theorem. This is a continuation of actually section 6.2. What is central limit theorem? This is central limit theorem. This is basically what central limit theorem is. We change sigma to, all the sigma becomes sigma divided by square root over n. N is number of samples, okay? Let's look at an example, okay? How this formula works on this actual example here. American Airlines uses Boeing 737 jet with 126 seats in the main cabin, 126 seats. So, those are the seats, right? Those are the seats, like that, okay? Those are the seats. Airplane, a lot of seats, okay? 126 of them, 126 of them. And then, they, used to be 16.6 inches. The seat is 16.6 inches. That was the width before. Now they changed it to smaller, 16 inches. So some people have a bigger hip size. They may have trouble sitting because the seat gets smaller. Why they do that? So that they can put more seats to make more money. Okay. Now, so here comes the question. The adult male have hip width normally distributed 14.3 inches. Normal adult male hip size is what? 14.3 inches. That's what the hip size, not the seat of the airplane, just the person, okay? The hip size is that, average hip size. Standard deviation, this is the mu then. Standard deviation is 0.9. 0.9, that's the story so far, okay? So now part A. Find the probability the adult, a randomly select, so one person, one adult. What is, when I pick this person on the street, say, what is the probability of that person, hip size is greater than 16 inches? Okay. You know the situation now, okay? Forget the airplane. We just want to see when you pick one person random, so you can think of just pick somebody on a, some Wilshire Boulevard or something, you know what I mean? Okay. So now, well, let me erase that right there. Okay, so now, when we have normally distributed, and then mu is what? 14.3. Mu is 14, so in the middle is 14.3, and then sigma is 0.9. Okay, so when you pick one person at random here, see, randomly select one male. What is the probability that a person hip is greater than 16 inches? This is 16. What is the probability that a person hip is greater than that? So greater than, so I'm going to put 999, 999, 69 minimum. So to find this probability, you do what? Normal CDF. Lower, remember, upper, mean, the mean, and sigma. So if you do that, normal CDF in your calculator, low is 16, upper is 999, 999, mu is 14.3, sigma is 0.9, okay? You put that in the calculator. I'll show you how to put that in the calculator here. So I'm going to clear that. So normal CDF, second bars first, you have to go there. And then you see normal CDF in number 2. We did that in in 6.2. So now, put the numbers in that order. 16, comma, 999, more 9, and 3 more 9. Okay, comma, minimum of 69. I say minimum. 14.3, comma, 0.9. Close parenthesis. And you get about what? 0.02945, blah, blah, blah. So when you round to 4 decimal like that, this is 2.0295, because this 5, because this 5 or greater, then you move this one up. Or you can say 2.95% chance that that person, you just pick somebody walking on the street. That's random. Okay. So what is it? Probability of this person hip size greater than 16 inches. That's the story. And that, what is chance? What's probability that person hip size greater than 16 inches? 2.95%. Okay. So if you look at the textbook, that's video technology. So, we are much, so this is what it is. 0.0295. Okay. 0.0295 right there. Just part A. Part B. Find the probability that 126 main cabin seats are all occupied by male, with hip greater than 16 inches. It's not just one person. One person. All airplane, okay. You have so many seats, right? 126 of them. What is every seat? Every seat, probability of every seat is occupied by male, okay, by 126 males, hip size greater than 16 inches. That is the probability we're trying to get it. So, what do? This is what the central limit theorem says. This is where central limit theorem comes in. Okay, central limit theorem says normal CDF, low, upper, mu, the mu I said, did I say mu? Yes, then it's mu, okay? Mu, and then next one I'm gonna change sigma divided by square root of n. That's how it's gonna change. Okay, compare that formula with this formula. What is the difference? They're all the same, except what? This sigma will change to what? Sigma divided by square root of n. N is number of sample in this case. N equal 126. Okay, 126. So if you put that in the calculator, it's going to be normal CDF. Low is still, what is it? 60. Upper is 999,999. Mu is the same. Mu is 14.3. Now it's changing. Sigma. It is 0.9. It is, It is 0.9. It was 0.9 before. Do you see that? Now this time divided by square root of 126. Okay. So put that in the calculator. I'm going to clear that. Normal CDF, second bars. Go to normal CDF. And then 60 comma, 999, 999, at least 6 nines I said, and then 14.3, comma, now what? 0.9 divided by square root of 126. And you have to close parenthesis for the square root. You have to put another parenthesis for the entire thing. Okay? And then you're going to get 0. This is 0. Why it is 0? Because it is so many zeros. Okay? There may be some numbers after that, but so many 0 up to here. Up to 6, 0. So it is 0. That's almost impossible. And all 126 people, their hip size is greater than, 16 inches. So if you look at it, part B, it is very small, 0 plus. Okay? So it is, we can consider that is 0. I mean, impossible means what? Probability is 0 means what? Impossible. Okay? For all 126 adult hip size greater than 60 inches. Okay? So that's the story. You can read the interpretation. Okay? Let's look at another one here. This kind of long question here. So here, now body temperature of adult is 98.6 Fahrenheit. And then standard deviation is 0.62. Okay. So when you pick 106 people were randomly selected, okay. And when 106 people, when we measure their body temperature, was 98.2. We have how many people? We have how many people? Okay, it doesn't have to be male, it can be male, female, all 100. How many? 106 people. Okay, 106 adult. I think it's adult, okay? Now, and their mean temperature was 98.2. 98.2 degrees. Okay. So, question is, if mean body temperature is really, we believe that was 98.6. Okay. This is, we assumed body temperature is 98.6. So, but we take 106 people and we measure their temperature. It came out to be 98.2. Okay. The question is, find the probability of getting 98.2, okay, or lower for the sample size of 106. Okay. So what are you going to do? We are going to, that's the story here. Mean was 98.6. What is the probability of, this is 98.2. What is the probability of 106 people, their mean body temperature is 98.2 or lower? Okay, 98.2 or lower. What is the probability? So we do normal CDF. What is lower? You go this way now, to the left. So you're going to have negative 999, 999. So upper is 98.2. Oh, you the lower first. So you're going to do lower. So you're going to put negative 999,999. Okay, here. Come on. Okay, so you put, instead of 98, come on, negative 999,999 first. Negative 999,999. And then, what is it? 98.2. 98.2. And then, 98.6, that's the mean. What is standard deviation? 0.62. But remember, you got to divide by what? How many people we're talking about? 106. So square root of 106. That's what you need to put. Okay. So go to calculator. Okay. Then no. Okay, here. So now turn on the calculator. I'm gonna clear everything in normal CDF, second bars, and then go to number 2, normal CDF, and then negative 999,999, comma 98.2, comma 98.6, comma 0.62, divide by square root of, what is it? 106. Okay, close smaller parenthesis and close large parenthesis. So the probability is, what is the meaning of that? 1.552, 10 to the negative 11. That means 0.0000. How many zero? How many zero? How many zero? 10 zeros. Okay, so this is almost impossible. Okay, so when you look at it, if you use technology, we get this. Okay, point, no, one, not 9, 1552. Okay, so remember I said 10 0. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see that? 10 zeros. Okay, so this means point. I'm talking about this one. 1552. This is what this means. Okay? All right. Okay, and then I think that's all you need to know. And then we're going to do quizzes. Okay?